This conference will now be recorded.
So, very good evening, students. Today we'll conclude this chapter, revision of this chapter, ray optics, by discussing few important questions from previous year's JEE Advanced paper. So, let us start our discussions. So, this problem is from JEE Advanced 2015. The problem says a monochromatic beam. So here actually in this kind of problems there is no options given. You have to directly find out the value, okay, in integers, in integer number. A monochromatic beam of light is incident at 60 degree. This is 60 degree on one face of an equilateral equilateral prism of refractive index n, and emerges from opposite face making an angle theta n. This n is refractive index, so theta n, this particular angle of emergence depends on the refractive index n of the material. That's why it is a function of theta, function of the refractive index. That's why theta n is being written with the normal. So this makes an angle. So emergent ray makes an angle theta n with the normal to this face AC. Okay, for n is equal to 3, the value of theta is 60 degree. I think this is not n is equal to 3. This is n is equal to root 3. For n is equal to root 3. For n is equal to root 3, the value of theta is 60 degree, and d theta dn, that means this variation of the angle with respect to refractive index is m. So then what is the value of m? This is the question we have to solve. So look, monochromatic ray is incident at the face AB of equilateral triangular prism. You can see that. So this is angle of incidence. Generally how we name the angles, this is I. Sometimes this is I1, this is R1, this is R2, and this is I2. Like that we generally name it. But here it is given as theta anyway, it doesn't matter. So a ray which is refracted through this face AB is passing through the prism and emerging from the other surface AC, making an angle theta n with respect to the normal drawn to this AC surface. So this is the question. Now you have been given n is equal to root 3. When n is equal to root 3, then theta is 60 degree, and d theta dn is equal to m. That is the variation of this angle of emergence with respect to refractive index is m. So what is the value of m? Now we know for prism, see R1 plus R2, R1 plus R2 is a angle of prism, right? Now you look, this angle of incidence is 60 degree. So what I can write for this, see, applying Snell's law, Snell's law, Okay, so if we apply Snell's law at AB and AC phase, excuse me, then what we can write from here, we can write n sine R1, okay, and further we can write at this surface n sine R2 is equal to sine of theta, right? These things we can write. Again, look, if this is an equilateral triangle, then angle of prism will be 60 degree, as we have shown you here in this figure. Then you look, this sine theta can be written as n, let this be equation number 1, n sine R2. In place of R2 I can write a minus R1, right? I can write that. All right, so I can write a minus R1. So sine a is 60 degree, so we can write here this as 60 degree minus R1. Okay, now this part, I'll take this equation forward. Sine theta is equal to n into sine of 60 degree minus R1. Okay, so n, so sine a, I'm just using trigonometric identities. Sine 60 degree cos of, so sine a cos b cos plus cos of, or here minus is there, so minus cos a cos 60 degree sine b. Okay, this is what we are doing here. Now look, with this we can put the values. Look, we can put the values, let this n be there, so this is root 3 by 2 cos of R1, and this is half sine R1. Okay, this we can write, isn't it? Now look, we have sine R1, we had written in the beginning. See, we had written equation number 1. This is, okay, if required we can just use this equation, like say this will be, I'll just write it here, this equation. See here, from here we can write actually sine R1 is equal to sine 60 degrees root 3 by 2 root 3 by 2n. If required we can use this. Okay, so look here, we have this cos R1. Why don't we write this cos of R1, so we can write 1 minus sine square R1, right? Now this also we can write, okay, sine R1 anyway we can have direct values. Look here, we can put this value sine R1. If we put the value root 3 by 2 here, square root of 1 minus, see it was here root 3 by 2, so if it is squared out, then 3 by 4 n square. Okay, and here it will be half, and this value is root 3 by 2n, root 3 by 2n. Okay, now further we can do a little bit of simplification. Root 3 by 2, then this could be written 4n square minus 3 divided by 2n. Okay, and here it is root 3 by 4n anyway. If we multiply n inside, then what we get? So root 3 by 4 we will get here, and then we will get this 4n square minus 3, 4n square minus 3, and minus root 3 by 4. Okay, so this is what we get. Now I can, so this is actually this is value for sine theta. Okay, so this is actually sine theta is equal to this, but we have to find out the value of d theta, sorry, yes, d theta by dn is equal to am. What is the value for that? We have to find out that. Okay, then let us go to the next page. Then we have sine theta is equal to root 3 by 4 square root 4n square minus 3 minus root 3 by 4. Okay, now if we just differentiate with respect to n, differentiating, let us this equation 2, differentiating equation 2 with respect to refractive index n, then what we'll get? We'll get cos of theta d theta dn root 3 by 4. This is there, then it will be 2 root of this part, and derivative of again this 2, so this will be 8n dn, and this will give you 0. Anyway, I'm not writing that, so it will be, so this 8 will be cancelled out, and look, this is then root 3n dn. I would not write this actually. Okay, cos theta d theta I should write, or I can just do this also, doesn't matter, we can just write this. Okay, so what we get from here? Root 3 n divided by square root of 4n square minus 3. So we have got this. So d theta dn root 3 by, sorry, root 3n divided by 4n square minus 3 into cos of theta here. Now look, we had been given that when n is equal to root 3, then theta is equal to 60 degree. We will put it here now. So m is equal to d theta dn when n is equal to root 3 root 3 is 3 again here minus 3 and this will give you cos 60 degree is half. Okay, so it is 3. This will 2 will go here, and from here 12 minus 9, that is, sorry, 12 minus 3, 9. 9 it gives 3, so it will give you 2. Okay, so this is the value. Okay, so this kind of question should be answered in integer number. So we have got m is equal to 2. So this is the answer for this particular question. So this question seems to be very small, but answer looks little longer. Anyway, it is very simple. You have to do in this way. All right. So this is the first problem, and m is equal to 2 is the correct answer. Okay, we don't have options for this kind of questions. We have to find out the number in integer. Now I have got another problem that is also very interesting. So look this problem. This problem is actually related to internal reflection, total internal reflection. So in that case, we'll go with the concept of critical angle, etc. Okay, so let us first read the problem. A monochromatic light is traveling in a medium of refractive index 1.6. It enters a stack of glass layers from the bottom side at an angle theta. From the bottom side at an angle theta, that is equal to 30 degree. The interfaces of the glass layers are parallel to each other. You see that, parallel to each other. The refractive indices of different glass layers are monotonically decreasing as Nm is equal to N minus m into delta n. I'll tell you here, see, I have different layers as you see. So 1 to up to m layer, and the refractive index of each layer is actually getting reduced according to this formula. Okay, if I take m is equal to 1, say m is equal to 1, then it will be 1 delta n. So only it is reduced by delta n. N is equal to 2, see here, n is equal to 2, it is reduced by 2 delta n, 3 delta n, like that it goes up to n minus whole into m minus 1 delta n, like that the refractive index actually is getting varied. You can understand this is, see, this is the thing happened in case of in the desert, where we see the reflection of water in the desert. Okay, actually this is actually the fact that the refractive indices of the layer in the air or the atmospheric layers, okay, decreases like that. Okay, refractive index decreases, and you know, this is the principle of mirage. With this principle, or with this fact, we can explain the mirage. Okay, in the desert, we explain mirage in the desert in this, like, with this particular concept. What is the concept? The concept is that the refractive indices of various layers of the atmosphere decreases as we go from earth to higher and higher. Okay, from the ground to higher and higher, as you see in this case. At some point of time, you look, suppose there is some water like some pond and some water is here at this place, suppose. Okay, at this place. Now the ray of light enters through this layer, bottom layer of the atmosphere, which has a refractive index greater than the other layers above it. Okay, so it is going from denser medium to, suppose this is some okay, denser medium to rarer medium. So what happens, as it enters, after refraction it is going away from, sorry, going towards the normal. Okay, not towards, sorry, it is going from denser medium to rarer medium, so going away from the normal. So at some point of time you look that the angle of incidence become the critical angle for that particular layer. Okay, with the refractive index, respective refractive index, we can find out what is the critical angle. Okay, and from that actually it will actually symmetrically come down here. Okay, symmetrically come down here. Then at this place you look water, the image of the water, this is real and this is actually image, this is image. So people will see like a person who is actually uh, walking in the desert, he will see this particular image. So this is image, not the real water pond or water source. It is coming somewhere from very far away. Okay, so this is the property of the refractive index of various layers, that it will be reduced as we go higher and higher from the earth surface. Okay, all right, so the question is, okay, here m into delta n is already given, that delta n is equal to minus, sorry, 0.1. Okay, and what else is given, n is given 1.6 and angle of incidence initially at this surface, okay, the surface or interface 1, it is given as 30 degree, right? Now the question is, the ray is refracted out parallel to the interface m1 minus, sorry, m minus 1 and mth slab. See this, there is an interface at this place, right? This is mth one, so this is mth and this is m minus 1 interface. At this place, say refractive index is such that, sorry, angle of incidence is such that this is exactly becoming critical angle to this particular interface. Okay, critical angle, so it will be then parallel to the surface interfaces. Okay, parallel to the interfaces, it will emerge parallel to interface. That means this angle of refraction will be 90 degree. Okay, so oh, this is giving a lot of trouble to me. I think I have to update it. Let me finish this class actually. Okay, so what I wanted to mean is that at this interface the angle, critical angle is 90 degree. I got this. Madam, actually, my PPT got hanged. I don't know what to do now. I have to restart the system again. It is already 4:10.
Screen not shared, Ram.
Madam, are you able to hear me?
I can hear, but I
Hello.
am unable to see the screen.
Madam, actually, my PPT got hanged actually.
Okay, tomorrow you take a class, that's all.
Yeah, I have to take that. Otherwise,
Close it,
it
Ram.
is actually on. Okay, madam.
Close.
Madam, can you end the meeting? Hello.
Hello, Ram.
Madam, can you end the meeting? Otherwise, the recording will be on.
Yeah, I'll do that.
Okay.
Yeah, I'll do that.
Thank you.